If you watched the previous video I did on minimizing the surface area of a cylinder, you already have some experience with optimizing cylinders. This video is going to cover the process for maximizing the volume of a cylinder, which is a very similar process to minimizing the surface area of a cylinder, because they both deal with optimization of cylinders.
I'm trying to find the dimensions of this cylinder with a maximum volume. We're being told that we have 600 centimeters squared of aluminum. In this case, we're being given the surface area. We need to determine the dimensions. We need an H and we need an R that are going to maximize volume.
And if you watch the previous video I did on minimizing surface area of a cylinder, we defined an optimal cylinder as a cylinder whose height is equal to its diameter, or has a height that's equal to 2 times the radius of the circular base.
So what we need to do is take a look at our surface area formula. We know 600 is our surface area, and we also know that our height is equal to diameter, that our height should be 2r. What we're going to do is take this 2, multiply by this 2, multiply r by this r, and this pi is just going to kind of come along for the ride. We end up with 2 times 2 is 4, r times r is r squared, not 2r. And we end up with this expression here. Okay, so thinking back to collecting like terms, these are like terms. They both have an r squared. Okay, pi is just a number, so I've got 2 pi and 4 pi. If I add these two together, I should end up with 6 pi, and I still have an r squared.
Next thing we need to do is get r by itself.
We're going to divide by pi, divide by 6, and our goal is to simplify this a little bit. First of all, let's divide 600 by 6 just to get rid of that 6 on the bottom. So we'll end up with 100 over pi, and then we're going to take the square root of both sides of our equation. You really just type this into your calculator. You're going to push your square root button, push 100 divided by pi, and you'll get 5.64 for your radius. Since we have our radius, we know our height is twice our radius, so we just multiply that by 2 to get our height. And since we have these dimensions, we can use them to determine the volume of the cylinder. So we know a cylinder has a volume of pi r squared times h. And again, I talked about that in the last example, but if you're still a little fuzzy on that, take a look at the video on volumes of cylinders. Really, all we're going to do is substitute what we know. We're going to sub in 5.64 and we're going to sub in 11.28 and just sort of multiply that string of numbers together. You're going to end up with 1,127, and that is centimeters cubed. That's your optimal volume for the cylinder. Your main concept here is just knowing that the height of an optimal cylinder is the same as the diameter of the cylinder, or 2 times the radius of the cylinder.
If this video helped in any way, feel free to like and subscribe for more mathematical chaos. And as usual, thanks for watching.